what he has done. I can show you the logic sent by that gentleman. So it was very simple. He did very correctly. So this is what this logic he sent it. Right. So the okay, just to quickly brief, like what was the question we asked? Actually, like we had the lube oil pump. The purpose of the lube oil pump is to cool down the turbine, and when the turbine is running, like we have got a start-stop button, one green color stop and then red color stop. Green color start is I001. It is connected on the first channel of the PLC, and then the stop button is connected to the I002, the second channel of the PLC, and then subsequently the two outputs, like the turbine run command Q001, turbine run command, and we had a cooling pump start command, actually, right? Start or run command. So we got a Q002. There's a two output, because like a PLC has to see, the PLC has to send a output to the turbine, and PLC has to send the output to the cooling pump, right? So the Q001 is for a turbine, so turbine command, and then we have got the Q002 is a cooling fan, cooling pump output. So like the logic is, the moment when I push and release the start button, it has to start Q001, which is a turbine, and immediately cooling pump is Q002. Both has to start, because the moment turbine is running, the cooling pump also has to start, because it has to circulate the lube oil inside the system, because while running the temperature will be controlled, like it will shoot up, but because the cooling pump is pumping the liquid inside, it will take the heat through the lube oil and then bring back the to the tank. So it will keep circulating, and it will try to maintain the temperature of the turbine, right? The moment when I push a stop, once we push a stop, Q001, which is a turbine, has to go off immediately. However, the cooling pump Q002, it should take time. It should not be like going off immediately. It has to stop after 10 seconds. In reality, it's going to be like a 1 hour, because 1 hour cooling is required generally, because the machines are very big. So the 10 second or 10 minute or like 15 minutes are not sufficient, because the whole heat to be taken. So this is going to run for a 1 hour and cool down the machine to the best possible, and then it stops by itself. There is no separate stop for the cooling pump. After you stop the turbine, it has to understand, and it has to stop after 1 hour. Right? This is the actual logic in any power plant. If you go to any power plant, right, all the power plant, the like either it is a steam driven or gas driven, or like whatever this different turbine driven system, finally it has to have the cooling system, and it has to cool down. If anything, if we say, if it comes to the turbine, it has to cool down. So for this, definitely you need this this logic to be implemented in any of the power plant, right? Right, let us see how this was built by one of your engineer. He understand very correctly, and he made it also. So like he put like a green color button to start this. So the moment when you push and release, the is a set reset flip flop. It sets the output, so the output goes to the turbine. Turbine runs immediately, and hence he passed through the off delay timer. Off delay timer makes only delay in off, but whereas in a start it goes immediate. There is no delay on the on. Only off there is a delay. So he connected through the off delay timer and given the cooling pump. So as per his view, like once he start push and release, the turbine starts, and immediately the cooling pump also starts. So both starts simultaneously. And then when you stop it by using the red color button, when you push it, you are resetting the output, which is going 0, and then the turbine stops immediately. However, the cooling pump won't go off because the off delay timer, it makes the delay in off. Like you switch it off now, but 10 seconds it will hold, because that's what in off it is making a delay. It's delayed off. So 10 seconds it will hold and then make it off. That's what the logic is made. The logic is 100% perfect, and it's really very good. I was very happy that somebody understand very correctly the logic. Right. So maybe like in order to realize the logic, we can implement the same logic and then we execute it to make sure this works the way how we explain now. Right. Let us try now. We do the same thing how he made, but whatever he made, that is the best possible way. I don't think we have another best possible way. So we have the 2 inputs, and we have a 2 output. Right. So we have 2 input and 2 output. The first input is for the green color push button. So I will say green, which is a okay. We will number it like the address. Address is like a 001 is for start, 002 is for stop, and 1 is turbine, and 2 is cooling pump. So let us see. Okay, the first one I001 we have given as a green, and then I002 let us give a red. So it's a red. So green we have, red we have, and then we have a Q001, which is a turbine, right? So we will say turbine, and then the Q002 is a cooling pump. So we'll say cool pump, cool, right? So now we define the initial IOs, like what is input and what is output, we defined it. So now basically like we have to build the logic, whatever he built. So I am following his the logic, the set reset flip flop. I'm taking the set reset flip flop, connecting the start green color button to the start, and connecting the red color button to the stop, and then the output command to the turbine. So turbine is connected, and then the off delay timer. He put an off delay timer. So off delay timer he put somewhere here, and then he connected the this off delay, and then further the to the cooling pump. So this is what exactly he made, and then he has given the time of 10 second, and you can say this. So 10 second he has given. Right. So this is what the exact logic he implemented. Let us try to simulate and verify how it works. So I'm going for simulation mode now. Right. So the first things like when we start the system, and I push and release the green color button, the turbine and the cooling pump has to start immediately, simultaneously. So I am pushing and releasing. So what is happening, like you can see the turbine and the cooling fan, it started immediately, simultaneously, right? Because the off delay timer do not create any delay on. It creates delay on only on the off. When you off, it will delay, right? So the on is simultaneous and both of them are running. So now if I stop it, when I stop it, with our requirement is the turbine has to go off immediately, whereas the cooling pump has to run for next 10 seconds, obviously 1 hour, but in our example, 10 seconds later it has to stop. So I'm going to do the off now. So I switched off. You can see the turbine gone off, but still the cooling pump is on. 6 seconds, 7 seconds, 8 seconds, 9 seconds, 10 seconds off. So basically 10 second it was in off and on, and then it switched off by itself. So this is what like a every power plant, wherever you go, anywhere you find a turbine system, this turbine system always will having the cooling system. Like I obviously, like these are all the interview questions. If you go for any power plant or whatever, hey, I know the PLC program and I know I have done the PLC program also. So you can ask me any questions. So obviously a question come across like this kind of questions, like and also they can ask you question also, like they say, hey, okay, tell me like what you know about the some logic, any logic in a power plant, right? So you can say this, yes. Anytime when you start the turbine and cooling system has to go on immediately, whereas when we switch it off, the turbine has to go off immediately, whereas the cooling system has to run for next predefined time. It can be like based on the design, it can be half an hour, it can be 1 hour, or it can be 2 hour, based on what is the volume of the cooling media is required. So that's what it do. So what will happen, like, see, this kind of like a you understood some basic knowledge of what is this system inside actually in a power plant. So that will make you get a some kind of positive impression on you, that something you know it, right? Hope it should be clear. If it is not clear, you can ask me, so I can hold for a 1 minute. I will hold for you to in case if you have any query, you can send a message to me. It's not a problem. I from now I hold for next 1 minute. Right. So so far there was no question and nobody's asked a question, and there is no text message also. So we presume that all of you understand the logic correctly. Right. Mm, right. So now, so far what we have seen is like we have seen the logic gates and or not NAND and set reset flip flop. All we have seen, and then next is like we have seen the timers. Like in the timers, the important thing is on delay timer and off delay timer. There are other timers also there, like on off cycle timer is there and weekly timer is there and multiple options are there, but those are like normally it's a very rarely used actually. As long as like you are knowing the on delay timer and off delay timer, the exact utilization, the exact purpose of that timer, then the remaining all nothing actually, because the remaining all is the same. Like once you understand this concept, those are easily understand. It is not a big thing actually, right? So we are clear about the timer now. So now we can jump into the counter. Like a counter, generally like these counters are like used on a the batch industries. Like how many numbers of batches produced. For example, if it's a glass industries, like the glass bottles are produced, and each bottle when produced they will use to count it, and then once the count is done, and then they will do the they start the packing, or they stop the process or whatever. Or maybe in a cement plant, the product like the cement powder, they used to fill in the bag, and once the bag is filled in, and then the bag will go out for the delivery. When it goes on the way, there will be a sensor. It will sense the one bag, two bag, three bag, four bag, and then if 100 bags are to be produced for loading a one lorry, then after a product producing 100, then that specific conveyor will stop, and then the other conveyor will start, and that is for the another lorry. So like this, this will shift the belt in a different route, so that it will be continuously discharge the predefined quantity used by the sensor and combination of counter in the PLC block. That's what the application. Just I wanted to make sure every function you need to have the some example. If you know the example, and if you build the logic, then that remain in your mind forever. Okay. So that's what I'm giving you. Every block you need to understand some example. With example, if you understand, it is easy to keep in mind actually, right? So so let us see the counter, how exactly this works. Just we are going to see only the counter, how exactly the counter works inside, and then what happens after the limit and everything. We are going to see it now. Okay, I will remove the timer logic, what we have tested now. We go for the counter now. So you can see under the counter, you can see up down counter. Okay, it can do it can count down, or it can count up also. Both it can do. That is based on how you are configuring this function block, right? So now I'm trying to pick up the up counter and down counter. I am picking up. I picked up. So one counter has come up, right? In the counter, if you see the first leg, see the counter has got a first leg. It is saying R. R is to reset. For example, let us say I have I have a 10 bottles. After 10 bottles, I wanted to reset. So every time when 10 bottle is finished, I want to start some motor, and then I want to reset the counter, and then I want to do again counting. Then whenever you give a high signal on this reset, it will reset the outputs, right? This is the counter, and then here what you can see, this is the count. Every time when a value changes from 1 to 0 to 1, right? 0 to 1, 0 to 1, then it will be counted as a number. It's not like when always 1, it won't count continuously, right? Because for example, if one bottle is produced, when bottle is moving on a belt, when it crosses the sensor, it gives a 1. When it moves away from the sensor, the sensor will give a 0, which is means like a 1 means voltage, 0 means no voltage. That's what it operates. So when the bottle comes nearby the sensor, it will be 1. When it goes away from the sensor, it becomes 0. The next bottle comes 1. When it goes away, it is 0. So continuously 1 0 1 0 1 0 1 0 comes. So that is what we are going to connect on this count. When you connect that, every time when it passes from 0 to 1, the counter will count the value, and then it will display how many of item has gone, right? This is like a direction. Remember, like we said, one counter, it can be used for up counter or down counter. Up counter means it starts from 0, 1 2 3 4 5 6 7 8, like this it goes. Whereas a down counter is you will have like a 50, and from a 50, 49, 48, 47, it starts from big value to the 0. That way also you can configure actually. right? So this is a parameter which is like what you see on the left side. This is for the serial communication, and whatever you are configuring internally, that will be visible. We can see what is internal, and then we can visualize what exactly it is. So far it should be clear. So basically our interest is on the reset and then count. Okay, now if I go inside, double click on the block. This gives them there is a two item: on threshold, off threshold. On threshold means when do you want this block to be block output to become on? For example, like when 5 bottles are produced in the company, and I want to start some motor, then what we put is like a, you can put a 5 here. So what will happen when the input what we are giving, the counter count C and T count, when the one bottle comes, the counter will count 1. But that time the output of the block will be 0 only. And the next bottle comes, the counter will count, the count becomes a 2. Still the output is 0. And third bottle comes, it will go as a third. Okay. Fourth bottle comes, the counter will make a 4. Fifth bottle comes, it will become a 5th. And the sixth one, when it goes, then what will happen? The output will come as a 1. That's what we said on threshold. When you, at what count you want to make the block on. And that on command, you can use it to start the motor, stop the motor, whatever you wish, you can do it, right? Then maybe like you have some option that after fifth count comes, maybe like you want to start it, and then you wanted to stop it maybe at a 10th count. It's just some example. I'm telling you like some kind of a requirement. Generally, it's not required, because generally the people used to use only the on. Once they on, they start the motor, and then they achieve the goal, and then again they restart the process. But there is another option also available with the block. If you wanted to switch off automatically without resetting it, also possible. Like when the when the sixth count comes, you can see this become on, and then seventh count on, eighth count on, ninth count on, 10th count on, 11th count it goes off. Okay? This is a off, when where at what value you want to make it off, right? So basically like, I'm not going to use this off, but still we can see it. Okay, we can see. First we'll check the 5, and then we look for the next one, right? As discussed, like the input for this counter will be like a digital input, like the sensor, whatever the sensor, like which counts the production. Either it could be like a bottle production, or it could be a cement bag production, or anything like any filling system, any filling system, whatever comes, there will be a one sensor. That sensor senses the object presence, and then it gives a 1 to this 1 to the PLC, which is 24-volt to the PLC, right? So that's what we are going to see. Like we are going to use this input, like we are going to take input, this input only coming from the sensor. Like when the bag comes, it becomes on. When the bag goes out, it will be 0. So then again next bag comes, it will become 1, and then when bag goes out, it becomes 0. So 1 0 1 0 1 0 comes on this input, right? And that what we are going to do, we are going to crank on the count, right? Because this is a count. You will be very careful. It should not be given to the reset. Then it will always, it never run again, right? So now we have connected the count, and now let us execute what is happening with the value of like a 5. The our threshold is 5. Now let us execute this. So I'm in a simulation mode, right? This is our bottle sensor. Once the bottle comes nearby the sensor, is going to go on, right? Now you can see the count, the blue color, what you see here is now value got changed to 1, because it is counted 1. But remember, like it is always on. Still, if it is always on, it is not counting. As we said, the counter will count only when any counter, like any counter, the value has to go high and then has to drop 0. Then high. Whenever going positive edge, You can see the picture also, like a small arrow going up. Whenever it's going up, that means from value goes from 0 to 1. That is where the count starts. The count will add again, right? When it's on, it won't, because the bulb, there is a bottle moved, maybe it is got stuck somewhere and sensor is sensing, but it should not be counting like a 1 2 3 4 5 6 7, but actually they got stuck actually. So that is why they made a mechanism. The bottle has to move out. Once it move out, it'll sense, okay, it'll become a 0. So 1 0 1 0 1 0 comes, then it is a really correct mechanism, right? So if I'm going to make it off, so now when I'm making it off, still remain 1, there is no change. Again, when I make it on, then you can see the count here. Right now you're seeing 1, it can go to 2. So I'm making on. So you can see here the output has gone to, the count has gone to 2. And then going off, remain 2. Going on, okay, then the bottle gone out, 3. Then bottle coming in, 4. Bottle going out, no count. Bottle coming in, yes. Now it sends the 5th bottle, right? So you can see here, like the one, since we put a count 5 and 5 and above, if it goes, the output become on. Now we can use this output to start the motor, stop the motor, whatever the logic you want, you can do it, right? Now, if I say increase, what will happen? Like if it goes more than 5, let us see. Count is 5. Now count is 6. Off. Count is 7. Count is 8. Count is 9. Count is 10. So it will keep counting. It won't do any action, because we have given only one action, that if the count value is more than 5, then the output has to become on. And that on, you can use it for start, stop, or whatever. That's what we have given. That is why, like the keep count is going up, there is no action. Now remember, like when we explained, like very initially, we said there is an option for making it off also. For example, let us say my requirement, just my requirement is like when the production is more than 5, I wanted to start something, and my production is more than like 15 1 5, I wanted to stop the some activity. So then I can say, I can put a 15 here and say apply. Okay. So now what happens, like if I keep toggling this, which is like a bottle production, and once the 15 bottle comes, you can see the on will go for off, right? So I'm going to do it now. So now off, 11, 12, 13, 14. So 14 produced. Now if I make a 15, then we should see the output going off. So now the count has become 15, and you can see the output gone off. That means, like this is one of the option for you to use start, stop, or open close, something. If you want to do on a specific count, you can use that options, right? This is the one option what we supposed to use this. We have another functionality also with this. The functionality is like how to reset. Like right now we have a count of 15, right? If you want to reset, then we need to give a reset input high, then it reset. Let us check it, and then we'll proceed. Like say I will take a, like for example, we can use any of the one input. Like for example, like one of the input PLC input can be configured as reset the counter, reset the production, reset the total. So that way you can define, and then you can whenever you activate, it will reset. Like I'm going to connect it here, right? And let us try to check the simulation now. So let us say I'm going to make some counts. Right. So right now I have a count 7 production. 7 times I made a 1 0 1 0 1 0. So it counted a number 7, and the output also become on. Now if I push the input to on, then the count will go to 0. Since the count goes 0, obviously the block output also goes off. Right? Let us try to verify it and see. So I'm making it on. So I made on. You can see the counter got reset. It was value 7. Now it has become 0. And since it is 0, since it is not more than 5, the output become off. Right? I can take it out. It's like a pulse. But if I leave it always on, for example, let us say if I leave it on, always reset. Even if the count comes, it won't count because you are continuously resetting the block, so it won't execute. So you have to be little careful while doing programming or whatever. The resets should not be continuously pushed so that the block will go ineffective. Right? I'm removing this. So now, for example, like let us say I wanted to use okay, let me go to the offline. I want to use a one application like my requirement can be this way like after 5 I wanted to do automatic reset. How to do the automatic reset? Like what you can do is simply you can kind of output to input whenever the when you produce the as per this when you produce the bottle more than 5 numbers, obviously the output is going to become on. When the output become on, you take that on and give it to the reset. So immediately reset. Once it reset, the count will go for 0 and then output will become off. That way what will happen, every time the after producing the 5 counts, it become on and then immediately go off. But you can test it, but it's very hard to visualize. But still it is a you can see it actually. I can use slightly in a different way. It's supposed to connect, but it's not connecting. Let us try this way. I put this into R gate, and R gate output I'll put here. It is the same actually. See, it's a kind of like anyone comes is going to give a on. So right. Let us check the simulation now. Bottle 1, bottle 2, bottle 3, bottle 4. If I make the bottle 5, the output become on. And then once it become on, R gate will go here and it will become a 1. The 1 will come and reset and immediately go off. But maybe you may not be able to see it on your eyes because the execution is very fast. Let us do now. Right. So actually what happened, you can see the count becomes 0. It got reset. Technically like it has become on, and on has gone through this R gate, and R gate it has given a reset and it has gone. If you want to really test it, hey, I want to visualize correctly, then what you can do, there is an option to check it. Like for example, we can use the set reset flip flop to latch it. So that like we can at least we can find out whether it's going on or not. Just for a testing purpose. I'll go for simulation. So now the count is 1, count is 2, count is 3, count is 4. Then if I push now, the output of the counter become on. Since it become on, the R gate output will become on. Then on will come here and it will reset the block. Once it reset the count to 0, then this will become off. But very hard to see because from you cannot see the millisecond. But however, since it has become on, this on has gone to this block. This block will become on because it's set is a flip flop. It latches. 1 bit it will latch. So we can see it now. Right? We can say and go for on. So if you look at there, the output counter becomes 0, and then the output has became on, and then on has come and it reset. However, that one time on what has come, I latched. I could see, yes, it is confirming the on has come 1 pulse. which is a very short pulse, which is a millisecond, it catches the value. That's how it works. So now we all of us must be clear on the counter application, how exactly it is being used in the industrial environment. Hope it should be clear. If it is not clear, you can ask me. So I can repeat or whatever. So I can wait for next 1 more minute for you to reply in case if it is not clear to you. Okay. I'll start from now. 1 minute. I will wait for your feedback. So, guys, like I presume looks like the explanation is okay, and everyone is clear about the up counter, right? So now we'll go for further. We can go for a application now to understand how this applications is used in an industrial environment, right? We'll go for the application. So so I will make the new application. Right. Right. Let us say we wanted to try a packing system. The application what we are going to do now is for a packing system. So let us say we have a conveyor system. Just for a we'll put a some small picture to understand clearly. Let us say we have a conveyor. This conveyor is running by a motor. So let us say this color is the fill color can be black. This also can be black, right? So we have a start, we have a stop, right? And then assume that we have some bottles are going here. Okay. Let us take one bottle. Right. So let us take in a different route. So snip supposed to work, but it is not working. So I will take the print screen. So I will take a one bottle. Right. So we have a the conveyor system, the which is like the production of bottle coming down, and then we have a sensor too, like a the sensor which is sensing the bottle movement is like a, they used to call it a proximity sensor, like a, I think we have seen the last time we have seen the proximity sensor. I will tell you like how exactly that works. We can say it is the straight one. Straight one. Let me see, right? This one we can take. We can take this sensor, but so what exactly this done is like this one generally like this will have a in the tip in the front fascia. Normally it has it will have two colors like this is two colors, and let me make these colors. Red. So generally like the sensor will have a one transmit, other one is receive, right? So this transmit, when the bottle moving here, what will happen, this one will fall on this the the glass, like it falls, this one make the it falls on it, huh? Once it falls on it, it will reflect, because it's a light, so it will reflect to the it reflect back. So once it reflect like this, it will send a signal, and when the bottle comes, it will strike on the bottle, and then it will reply back. When it's reply back, then this will give a 1. The sensor will give you a 1, and that is what we are using in your program, that there's a one bottle has come. But once the bottle has moved, for example, like when it moves here somewhere like outside, right? So when once it is moved back, so now what will happen, like this one, it'll keep going, it never comes back, right? So it'll keep going, it never comes back, then it becomes a 0. That's how the it makes a 101010, right? So right, so we see that this just to make understand like how this bottle count is being sensed by the sensor. This is how it senses. So this is the conveyor motor, we can say. We can say conveyor motor. So conveyor motor, conveyor motor. And then we can say the address of this can be Q001. Now the bottles are being produced by this the downstream mechanism, and it is coming through this, and after from here, normally what they do, they will have the mechanism to packing up, like so there will be a package will be there. Just I will make a small kind of the package here. Let us say this packing system, and packing system normally they also will have a small moving mechanism, like a small motor. So like normally it will be this way. When the bottle comes, generally like it goes inside the packing system, and then this is another motor. This is the packing motor, we can say copy paste. this is the bragging, the packaging. The packaging motor, like once the package is full, it will start by itself. Like yeah, that's what we are going to do a program. And once it start, maybe like this can go. There will be like a distance. Like for example, let us say this can be from this. What we can do is from here to here, like from here to here. Maybe like here, it may be some kind of the vehicle or some kind of lorry, something can be there, or like a very big mechanism where it can fill it up. But this distance can be like, for example, 5 meter. You can say the distance between the packaging motor and the final destination can be 5 meter. We can say meter, 5 meter. Right. And then we have a common start stop. Let us say this is color. We have a red color. Right. So this is like a typical bottling system, bottling plant. Generally, the bottling plant, they produce the bottle from the big clan, and and then they, once it is produced, it will be cooled down, and then after cooling down, it will be going through the conveyor. It will check the quality and it check the count, and then after the count is finished, it will package into the packaging location, and then it will be shipped to the final location. Like I said, this is like the last one what you see, maybe like that is the final location. This is like a warehouse, you can say, like this is a warehouse. That's for our understanding, like a simple understanding. It's a warehouse. So now the logic, like what we need to build is like so this one is going to be like a motor, packaging motor. This one is going to be this motor, and then the address of this can be Q002. So now the logic can be this way, like the logic can be this way, like after a 10 motor is 10 bottles are produced. Like assume this way, after 10 bottles are produced, so what will happen? The counter is going to count one by one, and then 10 is finished. By the time this packaging machine would have got 10 bottles inside. Every 10 bottles were produced, then it is like a one package. It's only packed. So it is not at a 5. Generally in industry, like it will be like 100, 200 numbers will be there. Just for our examples, our understanding. Once the 10 falls inside, that means the package is full, and then this motor we need to start it, because it's supposed to take the material to the warehouse location. So once it starts, then from there it has to pass to 5 meter. Generally, since it is a fixed speed motor, the speed is same, constant. For 5 meter, maybe like it can reach the 5 meter in a let us say 10 seconds, for example, right? In 10 seconds. So what they do in a 10 second, they stop it. So it takes this. You can say. To well establish, we can say this way, and this you can bring it down, and once it is started, again this is a small conveyor only. This is a conveyor item, conveyor mechanism. So this one will move on top. Yeah, this one will slowly move and reach there again. So okay, right now the requirement is like once the 10 number of bottles are produced, the package will get full. Once the baggage gets full, we want to start the packaging motor. The motor has to start, and the motor can run for next we can say 10 seconds, because in a 10 second I'm sure this would have moved to the final location, right? So as and when it produce the as and when it starts the whole system produces 10 bottles, it has to be a 10 bottle package has to move to the warehouse, and once it is moved, then it can stop, and once it stop, this can start. See, the continuity you need to understand correctly. So let us say, for example, you can use this also. Like, okay, we don't go to that complex. Actually, we will go to the complex in the next phase. Like I can explain you one example, and then I can tell you. I'll ask you to do it, and you can make it and send it. And then if you have sent, and then we can use that example to define. Otherwise, like I can demonstrate everything. But time being, what we can do, as and when the bottle produces, after 10 bottles produced, we want to start the motor. After starting the motor, maybe like a 10 second later, we want to stop the same motor by itself. This is the logic. So basically, like the bottles are going to get counted. Once the 10 bottle is finished, we want to start the motor. Once the motor is started, 10 second later, we want to stop it, because in a 10 second, this package would have reached the warehouse. Then no need to start further, no need to run further actually, because the conveyor belt it shipped to that location. Finished. That is the simple logic. We are going to do it now. Right. Is the logic requirement clear? Just maybe like I can, because like the logic supposed to be clear understanding. If it is not clear, then maybe you can't follow up, right? So if it is not clear, also you can ask me. So I can stop for a 1 minute to get you the feedback. In case if it is not clear, the explanation, or if the requirement of the logic development is not clear, you can ask me, right? So I'm going to hold for a 1 minute from now for your feedback. So like looks like everyone is clear on the requirement. So I'm happy that everyone is clear. If everyone is clear, right. So I'm going to go for the remove the simulation mode. Right, delete everything. Right. The bottle sensor address. Like let us give a bottle sensor address also, so that like it will be clear. The program can be clearly understandable. The bottle sensor. This is a sensor. The bottle sensor address can be 3. So now the logic I do is like there's a big logic involved in this, but I'm not going to do it. But just for I'm going to do only one small logic, small portion of the logic. The small portion of the logic is like the sensor is going to sense. After 10 seconds, start the motor. After starting the motor, 10 seconds later, you stop it. So 10 second, 10 numbers of bottle production has to start the motor. After the motor start a timer. And once the 10-second timer is finished, you stop this packaging motor. That's what, that's it we are going to do. A small portion of this whole implementation. Right. So I'm going here, I'm taking the input, and this is my sensor. Like this is my sensor. Right. This is my sensor. and then I have the counter. I have up counter. Counter. So we have the input and we have a counter. So our logic is like a once the 10 count is finished, right? The 10 count is finished. We want to start the motor. So we want a motor also. So let us go for motor output. So we have output here. So like let us say I will say as a this is a packing motor. Pack MTR pack motor. This is a packing motor. We have a sensor here and we have a counter. Okay, we said if the count is more than 5, we want to start something like, so I put a 5. I put a 5. So now after 5, like I can count directly here, because once the 5 numbers of bottles are produced, the count is going to count 1, 2, 3, 4, 5, and then once the 5 comes, it's going to give output, right? So I can use this to output to start it, right? So then, and if I use it, what will happen? Like when this output is on, is going to continuously keep on. It won't stop further, right? If I connect this way. So I want to try slightly a different mechanism. If I connect directly, once the 5 bottle is finished, the output will be on. The on is going to be there, though it's going to continuously keep the motor on. But that we don't want actually. What we want is like we wanted to start it, but after 5 like a 10 second, we want to stop it. That is our requirement. So what I want to do, I want to do slightly different. So I will take this. So instead of that, I used to use set reset flip flop. Right. So set reset flip flop. I go here. I go here. Right. So now with this, what can happen? So when the okay, first bottle produced, the output is off, and you are not setting, so output won't be on. Correct. Great. It is okay. 2, 3, 4, 5. Once the 5 comes, it's going to set, and output is going to be on. Okay. And 6 comes, still it's going to be high, so it's continuously going to set actually. So now what I do is like after 5 seconds, the 5 comes, I'm going to reset this, so that like what will happen? It won't give continuous start command. So let us do that, like how we did for last time. We'll take the OR gate, connect this input, and then the output can go to the reset. What will happen with this? So with this, say OR gate, even it can be 1 leg or 2 leg or 3 leg. The concept is any one of the leg is 1, the output will be 1. That's it. So this, the logic implementation, what it does is like initially the number of bottle production is 1, 0. So output will be off. So since it is off, the motor is not running. Then when the sensor comes, it becomes a 1. Still the output going to be 0. Motor is not, the packing motor will be off. 2, 3, 4, 5. Once it comes 5, then output is going to go on. Then this will be going to set. Then the motor is going to run. Immediately the on command, on signal will go to OR gate, and OR gate will send a signal to reset, and it will reset, and then the output will become off. But still, though it becomes off, because we latch the last input, still the conveyor packing motor must be running. Okay. Now what we do, once the motor is running, we want to, as per our understanding, after the motor started, 10 seconds later, we want to stop the motor, right? So we are going to make an on delay timer. So 10 seconds we put, and then This 10 second, you can connect it to the reset actually. So now look at this carefully. Uh, very initially, the output of the counter is off. So off, everything is off. Once the count becomes 1, 2, 3, 4, 5, then 5 comes. The 5, the output of the counter will be on. You'll set the block, and output will be 1. Motor must be running, and the timer will start. Immediately, that output of the counter will go. The up counter will go off because of the reset. Still, however, the reset will hold the set reset flip flop, hold the last value, so it will keep running the motor. The timer starts from after the motor starts. The timer will run. 10 seconds later, it will come and reset the set reset flip flop and goes off. This is one way of implementation. There is another way of implementation also is there. You can use the off delay timer to implement. I'll show you how that is also going to work. So we can take this off delay, for example, right? You can use the same one. You can connect it here. That's why the logic can be built in a different way, whatever the way you want actually, right? It's a very powerful. That's up to you, like how you think. Your thinking can bring the multiple way of solution. So assume that like I'm making like another motor, like just for this is like, it's not the actual address. Actual address is Q001 only. Just for testing purpose, I am making another command. So this also will work. This alone can work. See, the result of the top and bottom is going to be same. I will tell you why. Let us say like the counter is counting. First time it will be off. So when it's off, the output will be off. 1, 2, 3, 4, 5. The output is going to come on. Once it become on, the output will be on. It goes via the off delay timer. The output become on immediately. Then immediately what will happen? This goes on. It will become a reset. It will become a 0. This goes to 0. But since it is an off delay timer, we configured as since we configured this as a 5-second delay, though the counter becomes the counter outputs becomes off, this conveyor run for 5 seconds and then it goes off by itself, right? If you see, the top result and bottom results are same, but approach is different actually. There slightly we used the set reset flip flop, and then we use the on delay timer. In the bottom we used only the off delay timer, and we achieved the goal, right? So let us visualize this result by simulation, and then we understand how we have implemented. Let us try to do the simulation. Go for simulation, right? So now the bottle production is a count 1. Only one bottle is produced. So the packing motor is not moving now, because not necessary, because the packing motor, it needs a minimum 5 product to be inside again, right? Okay, 5 or 10, whatever. Like we consider 5 now, right? So I'll go for off, 2, 3, 4. Now the 4 bottles are produced. So now if I produce a 5th bottle, you can see the output Q001, Q both will become on. Assume that both of them are same motor, but in a different implementation methodology. But just for your understanding, only this one, right? I hope we have entered the timing, 10 second here and 5 second. Okay, let us make 10 second here. Both are 10 second. Right. So now let us check the simulation. If I make it on, right, 5th bottle, 5 bottles produced, you can see Q1 also on, Q12 also on. Both will go off after 10 seconds. You can see it. See, 10 seconds later, both have gone off. Like, let us try again once more. Like maybe we can increase the time to 15 seconds just to visualize better. Go for 15 seconds. So now am I going to make the again 5 productions? See, now immediately the count has gone to 0 because it did a automatic reset after five counter. So we are going to make a again now on count number 1, count number 2, count number 3, count number 4. If we make a next count, the motor will start fifth count. So they made it 0. So now both of them are running, like both are output same. But 15 seconds later, you can see both will go off. That means the implementation is different, but result is same. See, both have gone off. So this is what like this is one of the application like see when you go for any interview or anywhere, like when somebody is asking about hey, can you tell me like the examples for the counter application, right? So this you can explain to them like whatever the graphics. See, that's why I brought we made a graphics also like how we built actually. I'm sure you also will be able to build the same graphic when you are appearing for interview or whatever. So you can say, hey, you can show, hey, this is the belt or glass tube and whatever. You can explain well, so people can understand very clearly that you understand technically in a very practical way, right? Hope it should be clear. But still, if I want to get your feedback, make sure you understand correctly. If it is not clear, you can always ask me. I can uh, hold for 1 minute from now for you to reply if I need to repeat something. So looks to be like everyone is very clear about the explanation. So I am very happy that everyone understand correctly. Yeah, one question is like so VVN asked a question. Instead of taking the R gate, can we use the SR latch? Yes, it is possible. Doing so, you can reduce one of the block. Yes, also possible. I'm going to do the same thing what you asked for. Like I can that way it will reduce. We don't require the R gate. See, this is what I'm saying. You like everyone thinks slightly different. It is not necessary that you have to follow me. That whatever I am doing, you can do. The logical thinking is different. Everybody can think slightly different, but the goal is supposed to be achieved. And if you are achieving your goal, very simple. It is very happy. Right. So now VVN said, why can't we use this the reset output to the set reset flip flop output to reset the counter? Yes, it is possible. Result are same. Let us try to do the simulation. With your logic, I'm going to simulate now. So I'm making a now counter is 1, counter is 2, 3, 4, and in a 5 now it has to start now. I'll say 5. Right. So fifth, yes, the counter got reset, and then you can see the both motors are running, and after 15 seconds they have to go off. Yes, both have gone off. So this is also acceptable to do the logic. So this is like a, I would say this is for this application for this moment. This is better implementation because you have get rid of using one more block, because reducing the number of block you can reduce the processor load actually. So processor load, if you keep always low, it is always advantage. It can be faster, it can be running without a bug or whatever. So less number of blocks are good actually, right? So we have tested the block what you have proposed. So now again I'm going to give you 1 more minute. If anyone have a question, you can ask, otherwise we can proceed. Okay, so now I understood that looks to be everyone is clear on the concept. I'm very happy. So we'll move forward. Now I will tell you the one of the logic requirement, and let me see how you can implement, and you can send me the implementation. So it's not necessary that it's supposed to be perfect. At least everyone has to attempt. But see, so far I have seen like only one person has attempted, and then he has sent the logic. I wish to see at least like 10 to 15 people if they can try, and then if they give something, it's good actually, because like it looks to be like only one person is giving correctly. That means like only one is understanding, the remaining or not understanding. That's what it says, but it's not the case. Right, we'll try now and we'll see. Hopefully this time I get a more print screens. Let us see. Right, the logic is now, when I start this button, right, the moment when I start this green color button, you need to start this conveyor. So that means like the conveyor is start producing, the conveyor is start moving, rolling. The bolts are keep start moving. Right now, the remaining logic is same. Like you can simulate the like input like a bottle sensor, and once the five numbers of bottles are produced, you can start this motor. But what you need to make it because it is rolling, because the packing equipment is moved out from this location and it has gone to the package area, until somebody put the next baggage, this belt should not be running. So initially when you push and release, this conveyor has to start, and 5 seconds like five bottles are produced. When the five bottles are produced, start this motor, but you need to stop this motor, because like you don't want this conveyor running, right? And then the once the timer like for 10-second timer is finished, then that means like this would have gone end actually. And then what we are doing, we are stopping this. Once you stop it, the system is ready to accept the further bottles. You can say you can start this conveyor again, because you want to fill it again. So once you start here, when you see, if you simulate 1 2 3 4 5, then you stop this conveyor, because these two are same actually. These are two point, whereas driven by only one motor. Stop this motor, start this motor. 10-second later, this would have gone to the baggaging area. 10-second later, you are going to stop this motor. The moment when you stop, you start this. It's a kind of a continuous cycle, like a production. We produce it, pack it, ship it. Then again produce it, pack it, ship it. Produce it, pack it, ship it. So this has to go continuous basis, right? That is the actual requirement actually. But in case you want to abort the whole production, then if you push the stop, that means everything goes stop. That means like no more movement, nothing can go, right? This is the chain will break. The continuous chain, whatever we talked about now, that chain will break, right? Little tricky logic, but if you can implement this logic, that makes like really like you have the better understanding, because looping is critical actually. Looping is here because like I'm sure you will write it. When you push it, you will start it. Once you start, five bottle comes, you will stop it. You start the packing motor. This will go to the packing area. Once the 10-second is finished, you need to restart the sequence. That is where a tricky part. But if you can restart it, if you're able to achieve it, it's really like a great achievement. And that gives a, that is sure, that means like it gives you understand the basic concept. And you can use anything. Like see, so far whatever we used, AND gate, OR gate, NOR gate, XOR gate, like what set reset flip flop, and on delay timer, out delay timer, counter, anything can be used. All you can use it, and then you try to achieve what we asked for, right? And also like a you can use the set reset the resetting, like either you can use the R gate to reset, or you can use the set reset flip flop to reset, anything you see, like it is up to you. You can freely use any blocks so far whatever we discussed, and try to achieve the cycling method. Actually, once I start, the production should start, filling should take place. Once I simulate the 5 bottle, then I need to stop the conveyor Q001, start the conveyor Q002, and then after 10 minutes, 10 seconds, you are going to stop the packing motor, and again you have to restart the conveyor. So again, the same simulation comes and all the things. It can be done continuous basis until I stop it. Once I stop it, even if I change the bottle count, like for example, if I change a 5 number bottle count, nothing should take place, because that is a maybe false. That's a false information, because I did not start the see without conveyor movement. How you get the bottle coming up? You cannot get it. So without starting, if I'm making a sensor 101010, it should not start anything, because my prime is on this start. The while conveyor running, while that's what like a when the conveyor running and the sensor senses, then you do the job. So like a, you have to say statement only. When you have a statement, definitely you will be able to achieve what I am looking for. So if you are able to do this, it's really great. So we can give a time from now, maybe like as now 11:48. So maybe you can take or like we can do this way. You can take time from now, like almost like it's 12 o'clock. You can take up lunch by 2 o'clock. We can come back in 2 o'clock. Like what we do, we don't proceed with any further subject. Actually, we go with only this implementation. Like whoever sent to me, we can put on this and we can try to simulate, and we'll see how much we learn, how much we understand. If not, I can develop and show you how it's supposed to be developed. But I would say you try your level best. You make it to some extent. Either it can be wrong or correct or not. That's not a problem. But at least you have to give attempt, right? So we'll stop now. You take your time. You have like 2 hours you have from now. Maybe you need lunch also, so you can take your time and try to build it and send me the picture on WhatsApp. By 2 o'clock we can come back and we'll try to evaluate and see how many of you made it correct and how many of you attempted. And if anyway, I'm going to demonstrate, but you try before I attempt, right? Okay guys, so now we will break. You can go ahead, but before we break it, if the requirement is not clear, if I need to explain what is the requirement, you can ask me. So from now, for 1 minute I will wait for your message or like call, and if no message, no call, then we can terminate, and then we can come back by 2 o'clock. So from now, 1 hour, 1 minute I will wait for your message. Yes, guys. So looks like everyone looks to be clear. So no explanation is required. Fine. Anyway, hope for the best. Like we will look for the logic implementation sprint screen from you, and we will meet again by 2 o'clock with your implementation, and we will check it out. Right? Okay, guys. Take care.